So, hi class, in this video we'll be learning about the basic function that is future value. The future value function is basically used when you want to determine the purpose that what amount you'll be able to accumulate in future if you start investing from today. And now your investment can be in two modes. One is the lump sum and the second is annuity. So the formula in the Excel, that is FV function, we can apply this function for both the such problems. And if you are starting with lump sum investment, let me give you one example here. So if I say that, okay, I'm investing 5 lakh rupees for 15 years and my expected rate of return is 6%, assumingly that we are investing in a very safer kind of option. So if we do that, so how much money after 15 years I'll be getting? Another example may be where I'm investing, 50,000 rupees per annum. And this is again, I'm investing for 15 years, but return is again the same value, 6%. But this is an example of annuity method. Another thing may be in real life that you are combining these things together. There are certain investment products which require, an initial outflow as well. Along with that, they expect you to pay something, additionally in terms of annuity format. That is a lump sum plus annuity mode of investment, where your outflows are actually combining both lump sum as well as annuity. So this Excel function, is designed in a way that it can accommodate all these situations. So let us quickly understand how we are going to do it. So the rate of return that we are seeing here is 6% in all the three cases. So let's solve one by one. So let us say the 6% rate is in the first case. The number of period, how many years you are investing here? You are investing for 15 years. In this particular example, in the first case that we are solving right now, we don't have anything, in terms of annuity mode. So we are not having anything in annuity format here. So either we can leave it blank or we can put 0 there. That will not make any difference. The present value, the principal value that you're investing right now, the present value that you're putting in the investment today is 5 lakh rupees. So please enter 5 lakh rupees over here. If you want to combine some kind of currency symbol here, you can definitely do that. So this is 5 lakh rupees I'm going to put in my initial investment. Now, because the annuity type is not there, it's not mentioned over there. So normally, for annuity type, we normally specify. I'll explain you that in the bottom part here. That whenever you are having, the regular annuity, which is the payment that is being done at the end of the duration, so then we call it regular annuity. And in this case, Excel function, needs to understand whether it is a regular annuity or the due annuity. So when it is a regular annuity, we have to specify type as 0. And if we don't specify anything, that will also give us the answer. And if it is a due annuity, so then you have to specify that, this is type 1 annuity, and that is where you'll get one additional duration interest value as well. So I'll explain you that both the things over here. So you have to specify whether it is type 0 or type 1. So however, because here there's no value of annuity, so this function technically means nothing here. So how can you do that now? So the future value function you'll apply, you'll say future value. The rate of return that we know is 6%. So we are going with 6%. Number of duration for which we are investing is 15. So we are just referring to that segment. The PMT value is 0. So PMT value is 0. Now the important thing is, because we are having some kind of input parameters here, either you refer it, that is okay, or otherwise you can type 0 here. The only issue with typing 0 here is that in the next round of formula, you'll have to edit the formula again and again, because when you specify 0, and in the next column we want to apply the same formula by copying and pasting it. So the 0 will be copied and pasted again. So it will not take up that particular value. So it is always good to refer cells as much as possible. So I'm not typing anything. I'm referring it to as 0. Then comma, my principal investment, the present investment that I'm putting into this has to be an outflow. So I need to apply one negative sign here, and then rupees 5 lakh. So it's an outflow technically. So I have to tell Excel that this is the money that I'll be paying off. Comma. The annuity obviously is not applicable here, but you want to specify that particular annuity 0 or 1. So again, for that purpose, I'm referring to this particular cell. So I'll just tell to the Excel that, okay, if it is regular annuity, I'll specify 0 there. If it is annuity due, I'll specify 1. So let me just close the bracket. The function is enter, and I'm just hitting enter. And my amount that I'll be able to accumulate at the end here is 11,98,279 rupees. So this is the money that I'll be getting after 15 years if my money accumulates at 6% here. Now, important thing is because in this function, if I use F2 function here, so it tells me, okay, all the cells are referred, here, nothing is typed. So this formula is good enough to be copied and pasted in the next cell. So if I just copy and paste this particular formula here, I'll be able to calculate values whenever I enter the values over here. So I'm just copying and pasting the same values here. The only thing that is changing now that my annuity amount is 50,000. This is the annuity amount that I'm paying per year, and I have nothing in terms of the present value investment. So I'm just removing it. One thing I should have done correct here, because now you're saying answer is negative, because the payment value itself is also a negative outflow for me. So I should have applied that negative sign here. So I'm just doing that now, and again replicating this formula here. So obviously the future value is something that you'll be getting, so it should be a positive number, it should not be a negative number. So 11,63,798 you'll be getting if you invest 50,000 rupees per year at the rate of 6%, for the duration of 15 years. So this is how this formula is now working well. So if I just copy paste this formula again here and let me see how does it work if I apply all these things together. So let me just put it here, and the only thing that I need to change now this time is my 5 lakh rupees of lump sum investment 2. So now at the end I'll be getting 23,62,077 rupees. So if you can see, okay, if you just add these two values, 5 lakh rupees for 15 years and 50,000 rupees per year for 15 years at the 6% rate, we can see that, okay, the sum is coming 23,62,077. And the Excel function, altogether is also giving us the same result. Now, the important thing is if I want to apply the same function, but I want to see whether, if this particular value is 1, then what happens? So if I am just doing the same calculation here, a future value, rate, number of years, comma, minus payment, I just picked that wrong. So number of period is in E5, comma, minus E6, that is my present value, the annuity value, comma, a present value that I am putting in, again a negative sign here, and this. And then because I want to calculate for 1, so if I just want to calculate for 1, so I'm just mentioning 1 here. So because I want to see if the annuity is due annuity, then what difference will be there. So I have deliberated, put 1 there, and then I'm just pasting this particular formula over here. And now what do you see? Obviously this function, total is exactly the same. So this time I'm getting slightly more amount of difference in annuity here. So you can see the difference value in lump sum is 0, because lump sum will not be affected by the nature of annuity. But when you see that difference is coming in terms of when you are having one additional amount of duration, the 69,827 is actually the additional amount of return or interest that you can accumulate if you go for a due annuity, because you have started making payment on T0, that is today. So 1 year additional interest is accumulated, and that's what the difference you will be able to see when you accumulate this corpus, and the same difference lies in that particular process. One important caution to be used in this formula: whenever your annuity is not perfectly annually. So if, for example, you are paying 5,000 rupees per month, and your lump sum investment that you have done is for 20 years. So then in that case, this time factor does not align well. So then this formula should not be used in a combined manner. I'll explain you what I'm saying here. So if I say this way, that I'm investing 5 lakh rupees today, and I'm not able to invest 50,000 a year, I'm investing 5,000 rupees per month. And again, for 15 years at 6%. So that way, if I'm doing, so then, what I should be doing, I should be applying this formula twice. So in this particular case, I'll be using future value of lump sum first, and then I'll be using future value of, just do it here. So what I'll do, I'll calculate future value of lump sum, and then I'll be calculating future value of annuity in 2 different parts. The only concern is because the annuity will be compounded on monthly basis, while this lump sum investment will be compounded on annual basis. So because we have two different periodicity of compounding here, then we should not be combining these two formulas together. So how the formula will work, let me just make you understand this here. And assuming that it is a normal regular annuity, so I'm just removing all that back to 0. So now what you'll do, you'll first apply this formula for the lump sum value. So let's say future value, rate is 6%, comma, duration is 15 years, comma, the lump sum value is 5 lakh. So annuity is actually 0. You have to specify 0 here and then minus this particular value, 5 lakhs. And because we are assuming it to be a, it's not an annuity. So the last function in this large bracket is actually not a compulsory function to be attached. So even if you don't put anything there, that will give you the answer. So let me just close the bracket. So I'll get the same answer here that we were getting earlier. So I'll be able to get 11,98,279, in terms of this regular lump sum investment. What I'll be getting in terms of annuity here, I have to apply this function slightly differently. The 6% rate is per year, and you are investing now, monthly. So this rate has to be adjusted for that duration. So we'll divide, for converting annual rate, we divide by 12 to get it, in this monthly format. So this is 12 divided by 12, comma. In 15 years, you'll be making, 12 times payment. So you'll be making 180 times payment. So you'll just take 15 multiplied by 12 here. And then moving forward, you have gone for an annuity investment here. This is 5,000 rupees. So I'll just correct it here. It is not 50,000, it has to be 5,000. So I'll just correct it there once I'm applying the formula. Comma, there's no, principal value constraint here. So I'll put it 0. And my regular annuity is 0 here. That means at the end of period, I can refer it or I can type 0 over there. So I'm just doing that and correcting one thing here because this value is 5,000 rupees. So now when you see that particular number, so you'll be able to understand, okay, my 5,000 rupees of investment is going to give me 14,54,000 something. So now if you add the total value, the total future value here, so you just need to add all these values over here and using this sum function, and 26,52,372 you'll be able to accumulate here if you go by this monthly mode of annuity. So the point, I hope that is clear, that when we are trying to have two different kind of way of compounding in terms of periodicity, one compounding is on annual basis, the another compounding is on monthly basis, then we have to use this separate method. We have to calculate first of all this future value of lump sum, then we calculate this future value of annuity, and then we add them together. This is what you get as a total future value. So this is the basic narration of this particular function of future value. Thank you.